Hey there everyone, thank you so much for being here, thank you so much for watching. In today's video I'm going to show you how you can create a completely free, completely DIY wireless mesh system with an open source firmware called DD-WRT and a few devices you may have lying around the house. With DD-WRT you can configure your devices to become a wireless mesh system, and you can even configure them to become a building-to-building bridge. In fact, I encountered the need to provide temporary connectivity to several container offices, and I used DD-WRT to create this bridge until permanent equipment arrives, and it was rock solid. So there are a few advantages of using this method, but there are a few disadvantages. Now I know that DD-WRT was mostly popular back in the day before all the off-the-shelf wireless mesh system from Netgear, from Google, from all the major providers. But DD-WRT can still be relevant if you want to go low cost, if you want to go DIY, and I'm going to talk about all the advantages and disadvantages, and I'm going to show you how to create this wireless mesh system. So join me in the computer and let's start rolling this. Alright guys, so we are at the computer, and before we'll just jump and start the technical work, there are a few things that you have to be aware of prior to starting the process. There are advantages and disadvantages to this deployment. The advantages are pretty clear. It's cheap, you're using a gear that's lying around the house, you don't need to buy anything. It's stable, and I've started before writing stable. There are TP-Link devices that might not work with Netgear devices. Netgear devices might not work with ASUS devices, etc, etc. There is no guarantee. But if you use devices from the same manufacturer, or better yet, the same model, you can bet you're behind it's going to be as stable as any other solution. So this is why it is indeed stable. But if you're going to pursue this kind of deployment, make an effort to grab devices that are from the same model. And flexible, because you can use it in this way, or this deployment this day, and change the deployment architecture completely the next day. Nothing is holding you back. But there are several disadvantages. For example, it's not plug and play like off-the-shelf solutions. This does need some technical skills to make this happen. It's unsupported, meaning that there are community forums available, but if you need professional help, you will not be able to just submit a ticket to DD-WRT. It takes away the 5 GHz band. We are doing something that the manufacturer of these devices did not intend them to do. This is why, unlike off-the-shelf devices that have 2.4 GHz, 5 GHz, and another third-way radio for a backhaul communication between the devices, we need to take away the 5 GHz band for this backhaul communication between the nodes, meaning we will only be left with a 2.4 GHz radio for client connectivity. We are using the 5 GHz because it's faster, we don't want any bottlenecks. And security, since we are using wireless routers that are probably very old, they are as secure as the vendor intended them to be. DD-WRT does not have any other software security features, so if you're looking for upscale security, this is not what I would recommend. These are the advantages, these are the disadvantages. And one small thing that you need to remember before jumping and starting to do the technical work: when you flash your device with DD-WRT, again, if you want to see a video about it, let me know in the comments below. Just before you shut down the device, take a note, just open a new notepad document and copy the 5 GHz interface MAC address. I will show you exactly where to take it from, but in order to make this deployment work, all the devices need to know the MAC addresses of the 5 GHz band of the other devices. Alright, we are ready to start rolling. Let's open up a new browser window. I've already connected the device that will be my primary device to power, and I plugged it with a network cable to my computer. The default IP address will be 192.168.1.1. I have just factory reset my device, so it right off the bat asks me to provide a username. Let's use admin for the lack of a better idea, although I would advise you not to use admin as a username. Let's set a password. Alright, so this is like the sort of the main landing page of DD-WRT. The first thing that we will need to do is to click on the setup tab right here, where we will need to actually log in. So this is the main device configuration page. This is where we'll set up the internet connection, if it's DHCP or PPPoE or etc. The device IP address, if it's a DHCP server or not. This will be our main primary device, so this will be the device that will be actually connected to the internet. So what we'll do, since it will be double netted for me, I will keep it as DHCP, but if yours is PPPoE, this is where you'll change it and provide the username and password. For us, it will stay as DHCP. Let's call this device primary. Now, since my device or my deployment will be double netted, I will need to change the IP address right here. I will change it to 10.0.0.1/24. I am going to use this device as a DHCP server, but the first thing that I will need to do right now, since I changed my device IP address, I will need to click on save. And now the range is updated to my deployment. I can leave it as starting at 64. I can set my NTP client if you need to use it. Click on save and now click on apply settings. This will actually do a sort of a commit in enterprise firewalls, meaning that my IP address right now is still on the old DHCP scope. I will need to do an ipconfig release and an ipconfig renew to get a new IP address, which needs to start at 10. Great, so I got a new IP address, and now I need to log in to this new router IP address, which is 10.1.0.0.1, and log in. Alright, great. So now the device is actually networked the way we want it to. And now we can start. Now, there are a lot of settings that we can fine-tune or mess around with. I'm going to try to keep it as simple as possible without changing almost nothing that we don't have to for the purpose of this deployment. Let's jump over to the wireless tab right here. And by the way, this is where you get the 5 GHz interface MAC address. This exactly right here. So what I have done prior to starting this filming, I created a notepad document with all the MAC addresses of my 3 devices, because device 1 will need to know the MAC address of 2 and 3, device number 2 will need to know 1 and 3, and device 3 will need to know 1 and 2. Alright, the first thing that we need to do is to configure the 2.4 GHz, which will be our regular client connectivity interface. We can do it, set it as N only. Wireless channel, preferably, now this may vary on your environment, but I usually set it as channel 1 and change the SSID to, I don't know, tech me out. Right. Now, for the 5 GHz band, this is where we'll actually need to do our so-called manipulation. From the wireless mode menu, drop-down menu right here, I will select WDS AP. Now, there are a lot of devices that DD-WRT is supported to be installed on, but not all devices have the same hardware. So if you open the drop-down menu right here and you don't see WDS options on the drop-down, that means that your device, sadly, is not WDS capable. I'm selecting WDS AP right here. Wireless mode will be N only. Now I'm not saying I'm not selecting AC only, because I'm using 3 devices where one of them is a bit of an older generation device that doesn't support AC, and I'm only as good as my least capable device. So in this case, I will stay on N only in 5 GHz. Channel width, I'm going to select wide because I do want the maximum amount of bandwidth to be able to go in the backhaul between devices. Wireless channel, I will select 36. In the wireless SSID, let's give it mesh, but I do not want to broadcast this wireless SSID. I wouldn't want clients to connect to this SSID. This will be used only as the backhaul between devices. Click on save, click on apply settings, just so we will be ready for the next step. Let's click on wireless security. This is where we'll add WPA passwords for our wireless networks. In my case, it's WPA, and I'm selecting AES, and let's select the password. Great. Click on save. Do the same for the 5 GHz radio, WPA. I'm selecting WPA2, AES. Click on save, and now select the password. Save and apply settings. We are working methodically, step by step, meaning that we are now ready to take the next step. If we go to wireless and the basic settings, we can see that the 5 GHz antenna is WLAN 1. So we'll configure our MAC address on WLAN 1. Now, what we will need to do on this page right here is to familiarize our primary device with the MAC addresses of our secondary devices. So let's go to our notepad. And in our notepad, I've already written the 3 MAC addresses for the 3 devices 5 GHz interface. And as you can see, I've already have my first AP MAC address listed right here from my previous tests. Let's change this to LAN. And let's change the next one to LAN. And let's start typing. Sadly, we can't copy and paste. We'll need to type the MAC address of the second access point. Alright, now click on save and apply settings. This is the step where we configured the wireless settings and the LAN settings of the primary device. There are a few things that I would like to do just before unplugging this device and connecting the next one. In security, I am going to disable the internal firewall. Now, I'm just disabling the firewall because I'm still at the testing phase of this deployment. Once I'm done, I do recommend that you try to re-enable the firewall, and if you still get connectivity, leave it on. But just for now, just because I don't want anything to be blocked on any level, I'm disabling the firewall. Let's click on save and apply settings. On the net/QoS tab, go to UPnP and make sure UPnP is disabled because we want the least amount of security concerns on this deployment. UPnP is not secure, make sure it's disabled. On the administration tab, right here, make sure the telnet management is disabled. If you want to enable SSH, we will need to switch to HTTPS, out of the scope of this video. Make sure telnet is disabled. Click on save and apply settings, just so we will be sure we haven't forgotten to save or apply any of the settings that we need. And so at this point, I will completely shut down my device and disconnect it and connect one of the access points or the secondary devices, and we'll continue to configure it just as we did this device. Alright, the second device is plugged in, and again let's do an ipconfig release. an ipconfig renew, because this device is probably still on the 192.168 subnet. Indeed. Alright, so let's log back in to 192.168.1.1. By the way, if you get to this page, make sure you delete the S in HTTP. Let's give it a username and a password. Great. Let's change the device name to access point 1, and the IP address we will also need to change to adjust to the new subnet, and let's give it a .2 address. Click on save, and on this device we do not want for the device to act as a DHCP server. We only have one DHCP server on the network, and this will be the primary device. Click on save. Now, just as a precautionary step, let's add the gateway IP address, which will be 01, and local DNS. Also, I'm going to change it to the primary device. Click on save and apply settings. Since we don't have connectivity to the main device, we will need to manually assign the network interface of our computer with a manual IP address. We don't have DHCP. So let's give it a .111, and it's 255.255.255.0 subnet mask. Alright, let's try to ping 10.0.0.2. Great, we have connectivity. So let's open up a browser and type 10.0.0.2. Great, we have direct connectivity to our secondary device. Click on setup and log in. Alright, for the WAN connection type, we'll actually select disable, because this device is not going to be directly connected to an ISP. Apply. And now what we'll need to do is to go into wireless, and on the 2.4 gigahertz we'll select N only. Wireless channel, I'm going to select 6 because I want the next channel that doesn't overlap with channel 1. And the wireless SSID will need to be exactly the same as the SSID on the primary device, which is Take me out. Great. On the 5 gigahertz antenna, we'll change it to WDS station. Wireless mode will be N only. Channel width will be wide. And for the wireless SSID, this will be also need to match exactly for what we have configured on our primary device, which is Mesh. Click on save and apply. Going to wireless security. Again, this will need to match exactly the settings on our primary device. So again, WPA, WPA2 personal, AES, the same password, everything is exactly the same. And for the 5 gigahertz as well, WPA personal, AES, save, the password field opens up. Click on save and apply. And going to our WLAN1 WDS, this is where we'll need to familiarize the device with the other two MAC addresses. So as we can see, we have from our testing the IP address of our base station, our primary station. So let's change it to LAN. And let's change the second field to LAN and add the second AP MAC address. So if this is AP1 and we already have this MAC address defined, we will only need to add AP2 MAC address. Click on Save and Apply. In security, again, I'm disabling the firewall. Save and Apply. And since this is a station device, meaning a secondary device, let's jump over to Setup, Advanced Routing, and change this option from Gateway to Router. Save and Apply. And just make sure, like the other primary device, that UPnP is disabled, Telnet is disabled, and at this point we are done with this device, and we can unplug it and plug back in the second access point for our final device configuration. Alright, so the third device is connected. In the meantime, we will need to change back our network card back to DHCP. And ipconfig release, ipconfig renew. Alright, we have an address. Let's try to log in. Again, if you get to this page, make sure to delete the S and just stay with HTTP. Great. Let's give it a username. Let's click on Setup. Again, WAN will be disabled. Let's call this AP2. IP address will be 10.0.0.3. Let's give it a gateway IP address, which will be 10.0.0.1. Local DNS the same. Disable DHCP server. Save and Apply. Let's quickly change back to a static IP address of 10.0.0.111, 255, 255, 255 for subnet mask. Let's make sure we have ping connectivity to 03. Great, indeed we do. Let's try to log in. Great. Let's click on Setup, Login, and just as we did before, we'll click on Wireless, AP, and only. Wireless channel in this case will be 11, which is the non-overlapping channel for channel 6. The SSID will be Take Me Out. And for the 5 GHz, we will select WDS station and only wide, and the SSID will be Mesh. Click on Save and Apply. Wireless security, again, the process starts all over again. WPA2, AES. Click on Save, select your password, let's jump over to Setup, Advanced Routing, and change this option from Gateway to Router. Save and Apply. Click on WLAN WDS, and now we need to familiarize this device with both the primary device MAC address and the first access point MAC addresses. So at this point, we are actually ready to test our deployment. I will hook up the first or primary access point to power and to the internet, to the WAN port, which will actually be double netted to my primary network, and then I will hook up just to power the two access points, and we'll start seeing how they connect to the primary device. Alright guys, so all the devices are plugged into power. the primary device is connected to the WAN, this will be a double netted situation, but it will be good enough to simulate an internet connection. And my computer is connected with a network cable to one of the LAN ports of the device. Now, I've changed my computer from a static IP address back DHCP address, and I got a DHCP address. And the best way to check, the first check that we should do is that if we have ping reply from all of the stations, meaning ping first of all from our primary device, which we are hardwired into, so this reply is not surprising. Now, keep in mind that the other devices, the other station point, the other access points are only connected to the primary device wirelessly. There's no cable connected between them. So let's see if our connection went according to our plans. I should also get a reply from dot 2. Great. And I should also get a reply from dot 3. Great, meaning all our devices are connected to the same network. This means that they are bridged or meshed to the same network. I was also able to access the web interfaces of all the devices. And on our primary device, if we'll go to status and wireless, we can see that both our clients are connected wirelessly. Our link speeds are good because they're right next to each other, but this means that our deployment is working, WDS is working, and in fact what I will try to do right now is to connect my computer network cable to one of the access points and not to the primary device. Alright, so my device is now connected via cable to one of the access points that we've configured, which is only connected to power and nothing other than that. Let's do an ipconfig release and ipconfig renew. Now remember, if I get a new IP address, that means that the station that I'm connected to has reached out to the primary device, which is the only DHCP server, and that was broadcasted wirelessly back to my access point that I'm connected to, and I got a new IP address from the main device. Great, I have an IP address. Now let's try to ping our, let's say, something on the internet. Great, let's see if we get DNS resolution. So let's try to ping www.google.com. Great, so we have full internet connectivity, even though we are connected to a station that is not connected via cable to nothing, basically. And let's also try to ping our primary device. And in fact, we get a reply. This is how this means that our connectivity is indeed working as expected, and we have a full-on WDS or wireless mesh system that's all on the same network, and you can bet that clients will be able to roam from one access point to another. And if you like this video, please give it a like and subscribe. And if you want to see a video on how to flash your device with DD-WRT firmware, make sure to leave a comment below. Thank you guys for watching, and I will see you all on the next video. Bye guys.